Hi guys, so today we're going to be discussing one of the three ways to solve limits of functions, and that would be solving limits analytically. Now in this particular method, we have here four ways for which we can solve for the limit. So the first one is through direct substitution. So this is done by evaluating our function through a value of x we are approaching to, and this particular method is applicable for all types of functions. Now, if our limit yields an indeterminate form, most of the time it would be 0 over 0. That's the time we can use the other method. So, the second method here is by factoring or simplification. So, this is done when we have rational functions or ratio of two polynomials. And what we do here is we will just get the factors of either the numerator or denominator, or sometimes even both, to simplify the function. And once the function is in its simplified form, we can go back to direct substitution to solve for the limit. Now for the third method, we have here the conjugate. So this is applicable for irrational functions or functions containing radicals. And what we do here is we will just multiply our original function by the conjugate of a certain radical expression in the irrational function, and that would simplify our irrational function. So once our function is in its simplified form, we can also go back to direct substitution to solve for the limit. Now for the last method, if we are evaluating limits of trigonometric functions, so one way to simplify the trigo function is through trigonometric identities or special trigo limits. Let's now solve problem number 1. We're asked here to find the limit of 2x squared plus 3x plus 1 all over x squared minus 2x minus 3 as x approaches negative 1. Now the first step here is to perform direct substitution, and this is done by replacing all variable x with negative 1. So I would have here 2 times negative 1 squared plus 3 times negative 1 plus 1 divided by negative 1 squared minus 2 times negative 1 minus 3. So simplifying, I would have a 2 minus 3 plus 1 on the numerator. Then on the denominator, I would have 1, then plus 2 minus 3. So simplifying, I would have an answer of 0 over 0, or this is the indeterminate form. Now, to find the limit of the function, since it is a rational function, we can perform factoring. So I will need to factor both the numerator and the denominator of our rational function. So I will start with the numerator. So I would have 2x squared plus 3x plus 1. So let's start by getting the possible factors of the leading term, and that would just be 2x and x. As for the constant term, its possible factors could be negative 1 and negative 1, or positive 1 and positive 1. And since I'm aiming to have a positive middle term, I would choose positive 1 and positive 1. So its possible factors would be 2x plus 1 multiplied by x plus 1. As for the denominator, I would have x squared minus 2x minus 3. Possible factors of the leading term is x and x. For the constant term, that would be, it could be negative 3 and 1, or 3 and negative 1. So to choose the right factors, let's consider the factor that would add up to negative 2, and that would be these factors here. So I can rewrite the factors of the denominator as x minus 3 multiplied by x plus 1. So by looking at this factored form, I can cancel out both the x plus 1. So that will give me 2x plus 1 over x minus 3 as the simplified form. Since it is now in its simplified form, I can now evaluate this one at negative 1. So I would have 2 times negative 1 plus 1 over negative 1 minus 3. Simplifying, I would have negative 2 plus 1 divided by negative 1 minus 3 is negative 4. So the limit here would be equal to positive 1/4. Let's now proceed to the second problem. So for this one, we are asked to find the limit of x cubed minus 7x squared plus 12x all over 4 minus x as x approaches 4. Let's start by performing direct substitution here. Let's replace all variable x with 4. So I would have 4 cubed minus 7 times 4 squared plus 12 times 4. Then all over 4 minus 4. Simplifying, I would have 4 times 4 times 4. That would be 64. Minus 7 times 4 squared, or 7 times 16. That would be 112. Then plus 12 times 4. That would be 48. Then all over 4 minus 4 is 0. So simplifying the numerator, 64 plus 48 is 112 minus 112. So that would give us 0 over 0, or this is the indeterminate form. Now, to solve for the limit of this rational function, we can perform factoring. So the first thing we can do here, since all the terms in the numerator contains a variable x, I can factor out an x. So that would give me x times x squared minus 7x plus 12. Then I would just copy the denominator. So 4 minus x. Now to simplify further, let's solve for the factors of the quadratic equation x squared minus 7x plus 12. For the leading term, or factors of the leading term, that would be x and x. As for 12, it could be 4, 3, or negative 4, negative 3, or it could be 6, 2, or negative 6, negative 2, or 1 and 12, or negative 1 and negative 12. So to correctly choose the factors of 12, I would need to choose a factor that would add up to negative 7, and that would be negative 4 and negative 3. So I can rewrite the quadratic equation as x minus 4 times x minus 3. Then all over 4 minus x. As you can see, we have x minus 4 and 4 minus x here on the denominator. So to cancel them out, I would need to factor out a negative 1 on the denominator. So I would just copy the numerator x times x minus 4 times x minus 3. Then on the denominator, let's factor out a negative 1. So that would give us x minus 4. So now I can cancel out the factors x minus 4. So that would give us x times x minus 3 over negative 1, or simply negative x times x minus 3. So this is now the simplified form. So we can now evaluate this function at x equals 4. So that would give us negative 4 times 4 minus 3. So the limit here would be equal to negative 4. Let's proceed to the third problem. So we have here the limit of square root of x squared plus 9 minus 5 over x plus 4 as x approaches negative 4. Like we did in the previous problem, let's perform direct substitution by replacing all variable x with negative 4. So I would have here a square root of negative 4 squared plus 9 minus 5 all over negative 4 plus 4. Negative 4 squared plus 9 is 25. So I would have here square root of 25 minus 5 over the denominator here would be 0. Square root of 25 is just 5. So I would have 5 minus 5 over 0, or this is simply 0 over 0, or this is the indeterminate form. Now to solve this irrational function, so what we can do is we can perform the conjugate. So what we will be doing is we will multiply both the numerator and denominator of our irrational function by the conjugate of the numerator. So I would have here square root of x squared plus 9 minus 5 over x plus 4 multiplied by the conjugate of the numerator. So to get the conjugate of the numerator, so I would just copy the first term, square root of x squared plus 9. Then I would change the sign of the second term. So instead of negative 5, I would write plus 5. Then over, I would just copy the conjugate. X squared plus 9 plus 5. The next step, let's multiply the terms here on the numerator. So I will start here by multiplying square root of x squared plus 9 times square root of x squared plus 9. So that will give us x squared plus 9. Next, square root of x squared plus 9 times 5. That would be 5 times square root of x squared plus 9. Next, negative 5 times square root of x squared plus 9. That would be minus 5 square root of x squared plus 9. Then last, negative 5 times 5, that would be negative 25. As for the denominator, so I will just copy x plus 4 multiplied by the square root of x squared plus 9 plus 5. As you can see, I can cancel out these two terms here. So I will be having x squared plus 9 minus 25 on the numerator. Then as for the denominator, I will just copy it. So x plus 4 times square root of x squared plus 9 plus 5. Next, I can further simplify the numerator. So 9 minus 25 would be negative 16. So I would write here x squared minus 16 over x plus 4 times the square root of x squared plus 9 plus 5. Next, I have here a quadratic function or difference of squares in the numerator. So its factors would be x plus 4 multiplied by x minus 4. So I would copy the denominator, x plus 4 times square root of x squared plus 9 plus 5. So as you can see, I can cancel out these factors x plus 4 and x plus 4. So leaving me with a simplified form of x minus 4 over square root of x squared plus 9 plus 5. So this time, I can now evaluate this function at x equals negative 4. So I would have here negative 4 minus 4 over negative 4 squared plus 9 plus 5. So this would give us, on the numerator, it would be negative 8 over square root of negative 4 squared plus 9 is square root of 25. Then plus 5. So it would give us negative 8 over 5 plus 5. Or this is negative 8 over 10. So its simplified form would be negative 4 over 5. So this is now the limit of the function. Let's now proceed to the fourth problem. So for the fourth problem, we still have an irrational function. So let's find the limit of x minus 3 all over square root of 4x plus 4 minus 4 as x approaches 3. So like we did in the previous problems, let's perform direct substitution first by replacing all variable x with 3. So I would have 3 minus 3 all over the square root of 4 times 3 plus 4 minus 4. On the numerator, I would have here 0. As for the denominator, square root of 4 times 3 plus 4, that would be square root of 16. Then minus 4. So this would give us 0 over 4 minus 4. And this is equal to 0 over 0. Or again, this is the indeterminate form. So to solve for its limit, let's perform the conjugate. So this time, I will need to multiply both the numerator and denominator by the conjugate of the denominator. So I would have here x minus 3 over square root of 4x plus 4 minus 4 multiplied by the conjugate of the denominator. So the conjugate of the denominator here would be square root of 4x plus 4 plus 4. So again, this is done by copying the denominator, then changing the sign of the second term. So what I write on the numerator would be the same as for the denominator. So I would write square root of 4x plus 4 plus 4 on the denominator. Next, let's perform multiplication. So on the numerator, I would just copy x minus 3 multiplied by square root of 4x plus 4 plus 4. As for the denominator, so since I have here the product of this new denominator multiplied by its conjugate, so its answer would always be a difference of squares. So to simplify this one, so what I would do is I would just copy what's inside the radical form, that is 4x plus 4 minus the product of 4 and 4, and that would be 16. So that would be its simplified form. Simplifying further, so I would have x minus 3 times square root of 4x plus 4 plus 4. Then on the denominator, I can combine 4 and 16, or 4 minus 16. So I would have here 4x minus 12. So what I can do is I can factor out 4 in the denominator. So I would have here x minus 3 multiplied by square root of 4x plus 4 plus 4 over 4 times x minus 3. As you can see, I can cancel out x minus 3 and x minus 3. So giving me a simplified form of square root of 4x plus 4 plus 4 over 4. So I can now evaluate this function at x equals 3. So I would have here square root of 4 times 3 plus 4 plus 4 all over 4. And this would give us a square root of 16 plus 4 over 4. Or this is 8 over 4. So its simplified form would be 2. So the limit here of this function is